Hey everybody, I'm here with Jeff Bisti. Is that right?
Yep, that works.
Uh, I'm David and Nimit, and today we are really excited to get to the bottom of the myth around COBOL. So many of you might have heard recently that a lot of these state systems are having issues with getting unemployment checks out because the system underneath that's running everything is built in this mysterious language called COBOL. Now, I'll give you honestly, my familiarity with COBOL is the only thing I know about COBOL is that Grace Hopper was very much involved in the creation of it. In fact, I think she's credited with inventing compilers in COBOL or A0, and then what later became COBOL was kind of that language. So that's the only thing I know about COBOL. But I've heard this meme for years, and I saw Jeff do a great video on YouTube where he went through the process of building a much deeper application than just Hello World in COBOL. And so really excited to kind of, and then Jeff also works in the mainframe community, helping companies run and deploy large mainframe applications. So I'm sure your phone is probably very busy right now. People trying to upgrade their system. So thank you so much, Jeff, for joining us, and we'd love to just maybe have an introduction of yourself, and then yeah, like your relationship to the COBOL, the language and the ecosystem.
Yeah, sure, absolutely, and thank you, David and Nimit, for having me. This is fantastic, and I don't know if you're both in New York, but it's just like a beautiful day out right now, and I'm in a good mood because it's nice out. It's funny with the whole. Let me just get to the phone ringing off the hook thing. When you work in the mainframe industry for a while, you build up relationships with the people that work on them all around the world. And the first couple of days of like being like, locked in our houses and dealing with like the shifting economy and everything, I called up a number of my friends. I'm like, how are things going? They're like, it's the same, but more. Like maybe we allocated a little more memory over here. We did this a little bit more, but like it's kind of the same outside of like certain, obvious industries, but they're all hanging tough right now. It's just like, all right, we're just doing it. My experience with COBOL is somewhat short and brief, but I mean, if it gets me on here, that's all I need. I've worked in mainframe systems, for IBM for like I think 19 or 20 years now, and it's always been something that I've heard talked about. The mainframe ecosystem is such a deep, wide ecosystem. Anybody who says I know everything there is to know about mainframes or enterprise systems, like you can, unless they're like one of two people on the face of the earth, you can just discount them right away because there's just no end to it. So when I've always heard about COBOL, I just assumed it's it's a good programming language because lots of people use it. And when this whole COVID-19 situation kind of hit, and the governor of New Jersey said like, yeah, we're having trouble getting these claims processed because things run on COBOL. I mean, people from all sides came out. People who don't know anything said, "I can't believe they run COBOL." People who did stuff in COBOL said, like, it's not COBOL's fault. And all these, these tempers flared up. And I prepared for all sorts of stuff with this COVID-19 situation. Like I was preparing for it like a snowstorm. You buy the bread and the milk and the fruit snacks and all that kind of stuff. Learning COBOL was definitely not on that list. But once that happened, people said, okay, we need to get out there and let people know that COBOL is fantastic. And I said, I want to learn like what it's about before I say anything, because it should be coming from a point of experience. And I couldn't pick out a line of COBOL from any other code at that point, to be honest. Like I just know that it's there, and it started a long time ago, and there have been new versions of it. So I looked up a couple tutorials online. I had actually been helping build a COBOL tutorial course. I was slated to do the video for it. So in the background, I was kind of learning it, by the way, but I hadn't actually written anything. And over the course of Easter weekend, I just started a brand new file, and I said, okay, how do you start one of these, COBOL files? Okay, it looks like this. Okay, well, that makes sense. There's different divisions and different statements go in them. And, piece by piece, like any other programming language, just said, how do I do this in COBOL? Okay, that's pretty good. Copy, paste, change to fit my needs. And little by little, it came together. And I said, this is kind of an interesting story right here. Let me put it together. I'm just going to put a cap on this program. It's going to take in 3 files, sort them by dollar value, I think it was, and print out the output. And I was going to make it run on a mainframe because that's where most COBOL code runs. So there's a little bit of extra stuff, we can get into that, some JCL I had to write to feed it the input files and handle the output. But, in the course of 2 days, I put that thing together. I went down to a studio that I have access to, set up a camera and talked awkwardly into that, for about a half an hour, drove home, recorded it and put it out there. And, it just really resonated with a lot of people who said, okay, well, now I know what COBOL is. That's all demystified for me. So that is literally my experience with COBOL. It's this and then this for all of 2 weeks.
I feel like COBOL is something that people know about, but also mainframes, right? We haven't.
Yeah.
I think most people now are familiar with the idea of cloud computing. Before there's cloud, there was, and then you mentioned JCL, and I'm just thinking about the old
punch cards,
right? And so I'm curious, maybe so you've been working on mainframes for. Are you a developer in the mainframe world, or what exactly is it that you help people do with mainframes?
So I started out as a tester, which is really just like a great job for me because I love code. I am not good at programming. I'm like one of those guys that knows everything about sports or cars, but is a terrible driver and can't hit a ball. So I love looking at code. I love going to code reviews and seeing how is that solved? Oh, that's fantastic. I can look at it after the fact and break stuff really well. And in testing, that's basically what it was. Here's a thing that we think works perfectly. Let's see if you can break it. And I started doing that in the mainframe world. I started testing mainframe network cards. And these are, on a mainframe, you have, I'll just give just
was
enough.
This while you were employed at IBM or you were just doing this for fun?
This is all at IBM. My first job.
I'm I don't even know how to start playing with mainframes. I've never seen mainframe for sale at Best Buy.
No, you might not. We can get into how you can get your hands on a mainframe. That's always been one of the big problems. I want to learn this stuff. How do we get on a mainframe? And for the longest time, the answer was well, you have to work at a bank. But I mean, there's the Master of the Mainframe contest. There's through the COBOL course that we just put up on Open Mainframe Project that gives you a login into a mainframe. So you can get onto a system and just start banging around right there. To really get into the guts of it, the virtual LPAR, the LPARs and the memory and all that, you kind of need your own, and most banks won't let you just try around, play around with it on the weekend. But I mean, there is lots of stuff to get into. I forget what the original question was about, punch cards and JCL and stuff.
Well, I'm just I'm curious, the growth of. I feel like the growth of COBOL with I'm not sure who's a wagon and who's a horse, right? But as businesses in the 60s and 70s were really getting into deploying technology to improve how they're running their operations, COBOL was the language that kind of drove that nuclear reaction. And I'm curious, what so you're helping companies test. What companies what else are they running? Or what are they using these mainframes for? Where do you find a mainframe inside of a company right now?
So anytime you see a company running business transactions that can't go down, or if you look at they have millions of transactions going through a day, and that transaction might just be go through every account and add 0.05%, or find the accounts with less than this amount and do this action on them. Anytime there's a company that processes a huge amount of transactions where 0.005% of those transactions failing or going into a weird state is completely unacceptable, either because of the business they're in or because of government oversight, regulations. That's typically where you find mainframes. So very, very large retail companies, banks, insurance companies, stock markets, governments, scientific fields, industry. And I'll tell you, those industries look at their mainframe systems kind of the same way that they look at their electrical systems. They don't look at their electrical grid as gee, what does this let us do? It's like, okay, we just expect it to always be there and always to work. So, when you think about like a bank, every single transaction going through that could be me sending $20 to a friend because he let me borrow his lawnmower, right? It could also be like a series of paychecks going out there. So there's a certain level of transactional accountability that really goes up there, where if a transaction gets stuck in an I don't know, maybe in between, maybe this went through, maybe this didn't kind of state, it would be terrible. There would be no way to run a bank. So Mainframe, every transaction that comes in is recorded like n number of ways at the same time. And if it goes through like 19 of 20 steps and then fails unexpectedly at step 20, it can be rolled all the way back to step 1, so that there's no like lingering effects of that, like, those previous steps. So sometimes it's not really the most glamorous stuff in the world, but when you think about like it's stuff that needs to go through, that's where you tend to find those systems.
So to me, it sounds more like the important part of what you're describing is really in software, right? That like the software has great traces of where things fail. There's some kind of ACID, like in like a database that has these ACID rules where you can confirm that transaction's complete and there's no just issues with writing data and overwriting each other's data. Yeah, and so I think that stuff is fair. But now I guess the question that pops in my mind is that all that seems like it's in software. So is now really mainframe just another word for software that's running on a server?
No.
Or is it really like, is it something different about the hardware?
Yeah, the hardware is special too. I mean, in a mainframe system, the middleware, like the database, the transactional systems, the stuff running all the languages on it, all that is aware that it's running typically on the z/OS, which is one of the specialized mainframe operating systems. z/OS has specific hooks in it that understands about the firmware underneath it. The firmware understands about the hardware that it's running on, and the mainframe has special memory registers and special operations that you don't find in commodity grade hardware. So it's really is from the program you write to the software it's running and the language it's running in, the middleware, the operating system, firmware, middleware, milli-code, all the way down. It's really something special and unique to that operating system. And just like one good example of that is this thing called parallel sysplex. If you have like 3 hours to go down a rabbit hole later on, like look up parallel sysplex, and it basically lets a bunch of logical LPARs, which you can think of as virtual machines running in the same mainframe hardware or across nearby mainframes, communicate with each other like almost like at memory speed. They literally have like a memory connection with one another. So when they're sharing a single database or a single transactional server, they don't have to like yell at each other like, hey, I'm going to go do something with this data. Nobody do anything at the same time. They all just know what one another is doing, and they can like queue up behind another. So they know like I'm third in line for this thing. And it lets you really streamline and serialize and optimize these batch operations. So it's not something you can really scale out. It's just like a typical network scale. And I'm not trying to sell anybody a mainframe. Trust me on that. It's one of those things that the minute I found out about parallel sysplex, I'm like, all right, put everything on hold. I need to learn all about this, because it's so architecturally pure and built specifically for business processing that it's like, wow, that's amazing.
I think one thing I'm trying to do is draw parallels to the world that not only I understand, but our students are coming from, right? And so we think of most of web application developers, I would think of like kind of N or 3-tier architectures, right? Mm-hmm. So they'll think of, you have your client, your server, where your client can kind of have all your UI elements, your design, and your server where you encode, increasingly a lot of the business logic, and then your database that you're relying on for transactional support and data storage, right? What you're describing there sounds a little bit to me like, is it kind of like a unified memory architecture that you might see in where all these different processes can communicate, into one big pool of memory, or all these cores can communicate to one big pool of memory? Or is it? I also think of from like the Erlang world where processes running across different servers, it's transparent to them which server they're running on. They can talk to each other. They can communicate back and forth regardless. I'm not. Is there an analogy for what you're describing there that maps to kind of this other world? Or
it's kind of like it's kind of like the Erlang example, except that the applications are we call them sysplex aware. They are aware that they're running in a sysplex. They know that before they do anything, they have to check with with their team, basically, like, can I do this? Am I waiting behind anybody else? But because they are communicating like at memory speed, it's a small bump in the beginning. And I have a little window here. Hold on. There we are. As they ramp up, the complexity stays flat no matter how many more systems you add. So the complexity adds in going from 1 to 2, from 2 to 200. It's just add more, and the complexity kind of stays flat. Just one other kind of a finer point on this: the parallel sysplex, the way these systems talk to each other, is you actually spin up. Oh man, we're getting into some fun stuff here. You actually spin up another virtual machine, an LPAR, called a coupling facility within the mainframe, which is basically just a bunch of memory with a bunch of methods around it. And it handles all the synchronization between all those systems. So it is really like the focal point of all those systems. And for high availability, you would have those across several other systems. You can fail and move between them all. So it's not like one point of failure.
So it's almost, I mean, so apologies to anybody who's watching this who knows about mainframes, because we're mainframe idiots. So,
oh no, trust me, mainframe people love hearing about mainframe from any angle.
Because so I feel like when I think about this, it's like these because I feel like all of this stuff for web developers has been crammed down into the database, right? Because a database, you might have like transaction lock queues or transaction lock providers, right? Say like I'm locking this stuff. And then the other thing I think about is that if you're scaling up databases, you might have like consensus servers, right? They say like, this is the current new ID. So you're saying that mainframes kind of provide this, but at the application level, like if you're working in COBOL with no database, but you kind of recreate all of these transactional capabilities using these facilities.
You would typically start out with your business logic in the COBOL code, and you would make it as kind of small and atomic as possible. Open this table, look for this key, update this value, and then get out. Right.
When I say open this table, do you mean like it actually will connect out to some SQL table?
It expects, and I don't know if this is mainframe specific or COBOL specific. Like on the mainframe, at least, you are defining. And I've only done flat text files, so this is I know that it's handling data coming in and out of databases as well. The transaction manager is what's going to actually broker that connection to a database or an application or a WebSocket. So it's basically going to boot up, for lack of a better word, this program and say, here's your input, here's your output, do your stuff. Are you done? Okay, cool. And then get out. So it's the transaction manager, which is like typically, I'm just keep unrolling this stuff, Kix or IMS or something like that. Those are some mainframe transaction managers that you will hook up to your COBOL program and say, okay, Kix, IMS, as you are seeing these transactions come in, which could be from a web server, it could be from an ATM machine, it could be from a cash register, it could be from whatever. It's just going to pick up the appropriate program, shove in the input, wait for the output, or whatever order, and then bring it back down. So it's the full stack of the web server and all that stuff isn't running in COBOL. And if you look at like the commands that are available in COBOL, it's purposely limited. It's do this math function on this data, find the average of this input. But because it is so it's gotten compacted down so far and so dense over the years, it really is like preferred in a business world, in many business worlds anyway, because I can show that to an accountant or an auditor and say, this is what my code, this is the actual business logic of my code. You don't need to see anything about the web server or the load balancing, right? This is the actual business logic. You can see where we open up the accounts, where we add in the interest, and where we get out.
Interesting. So COBOL, I guess you wouldn't view it as kind of like you're running a COBOL virtual machine that's taking care of all these
Oh, no.
sub processes. It's like something else controls it,
Yep.
activates a function in COBOL, and then COBOL does something, and then ends that. It's almost like a I mean, I know we call COBOL a structured programming language, but it's almost like a series of functions that are kind of stateless except for what comes in and what goes out.
Yeah, that's a good way of putting it. It really is. And like I said, I'm a terrible programmer. There's in every program every language I've tried to learn. I know there's a language out there for me, but I haven't found it yet. At every state, every time I try to learn, there's a point when it goes right over my head, and I'm like, "Oh, Swift, why did you do that to me? I thought we were friends, right?" With COBOL, it really reads from top to bottom, and it has these different divisions. So like the first division, I think, is like the environment division. It's like, okay, this is the machine I expect to be running. I expect this type of architecture. Okay, cool. Here's the identification part. It's written by Jeff Bisti, and that's my comments. And then like we set up the data. Here's the input. Here's the output. Okay, cool. And then eventually we get down to the procedure division, which is like where the action happens. And that's basically, okay, so that input that we defined, that output we defined, okay, do this with it, then do this with it. And if this happens, then do this with it. And then at the bottom, it's like, then we get out. So it's as simple as possible. So when someone says like, we have a program that's written in COBOL, especially if it's been around for a while, I'm no more surprised than if somebody says like, yeah, we solved that problem using math. It's just, it's a lot of the good programming, practices and disciplines and habits just kind of put into form. And if you look at some of the code, it's just like, it looks like English. A lot of it, you look at it and you think that it's like a comment or pseudocode, and it's like
it reminds me of SQL.
Yeah,
some of it, right? Because it is kind of meant to be read like English. But Jeff, I actually so my question is, I was watching the video that you put out about kind of your sample. You were buying audio equipment or something, and writing a little COBOL app, and so that was a relatively simple application, right? So how are like more complicated applications built and organized? And like, for example, in kind of more modern programming, there is this concept of object-oriented programming, or functional programming, and so there's these kind of ways of expressing chunks of code that you can repeat and pass along. So how does all that stuff work in COBOL? Like the idea of methods, classes, things like that.
Yeah, it's a great question. So there is an object-oriented version of COBOL. I know people that use it. I know people that like it. My take is generally, if I'm going to get into like more object-oriented types of programming, there's other languages I'm probably going to use for that, because I'm probably not running it on the mainframe. But for certain things, it makes sense to do it that way. Within vanilla COBOL, we'll say vanilla COBOL, there's this concept of paragraphs, and it took somebody saying paragraphs enough times when I'm like, that's a function. You're talking about a function, or like, but it's not really a function. It's because you I'm sure there's a way to do it, but you don't like pass arguments to it. It's all kind of one big flat landscape. But you define your code in these paragraphs. So you say, okay, this is the paragraph where I check for, I see if their account balance is over $8 million. And this is the paragraph where I check to see if it's below $5, right? And this is the paragraph where I do this. And if you were to like whiteboard out a program, which people should do, the stuff you put into the biggest boxes would probably be the stuff you put into paragraphs. So then you write out your paragraphs, and then within your code, you just say perform paragraph name, or you can say like perform paragraph name through paragraph name, and it will just go, okay, let me branch down here, bop, bop, bop. And then it finishes that last one, it jumps up there. Now, you wouldn't want to write a COBOL program as like one gigantic file. It would just be terrible. So what you typically do is you can extend like libraries, so like you do in any other language. So you would say, I'm going to extend using this program or using this file and this file and this file, and now I have all of those paragraphs and all that functionality available to me. So it's anybody who's familiar with like programming and anything other than like, you know, BASIC or maybe Pascal, like it's once they see it, they'll just be like, okay, yeah, I get this. It's the same as pretty much anywhere else, except I haven't looked into the object-oriented stuff, but it's probably very similar.
Do you, as you're talking about this, one thing that like, do you think the rise of like serverless programming is kind of a return to this idea of you have, you know, like someone writes a little Lambda function, and then the whole control structure of that Lambda function is outside of that function, right? And which is nice because the programmers are like, oh, I don't have to worry about some global state, some global hash table that could be messing up my, right? Is that similar, or is that not the right analogy?
Absolutely. And that's when I first, you know, microservices and serverless computing and, you know, obviously Lambda and, you know, OpenWhisk and all that stuff, when that came on the scene, the eyes of a lot of, you know, I will say top-down procedural programmers kind of lit up, you know, especially like my coworkers, like, I can understand this. This is something there's a beginning and an end to this. I'm just performing this core bit of logic right here, and I can see the beginning of it, the end of it. I can add my special twist on it and hand it off to something else to handle all of that other stuff that I'm not worried about. So that kind of 3-tiered structure, it scopes it very nicely. I think that a lot of the architecture and like the style behind COBOL lends itself to writing a lot of like the microserver or microservice and serverless type functions. The language itself might not be a direct translation, but yeah, I mean, if you can understand COBOL, you know, you can implement that type of logic.
You know what's this is just an aside, but I often think it's what's interesting about fields as they grow is that they kind of adopt their own jargon and practices, but when they start out, they oftentimes, you know, it's like the whatever field that came out of, and I feel like I see this now with as you're describing this, like in the 60s, business people needed computers to amplify business, right? And the computer people came in and introduced things like C syntax that was more. I would say C syntax is arcane or esoteric, but it's like it's optimized for the programmer, not for the business person, right? And so it's like it's almost like programming was taken away from the business people in a forceful, right? I don't know if the COBOL programmers view this like history or how did this happen where this thing was being written by tons of people solving lots of actual business problems, and all of a sudden C comes out and like people are like, hey, let's go down this total different path.
Yeah, I mean, you have to think about like what a computer was back in the 60s, because if you said the word computer back in the 60s, you might actually be talking about like a person, right? I'm a computer, a person who does the computing, so the idea of a programmer was like it's like a specialization of a computer right there, and like what makes up a transaction is you know, that hasn't even been defined yet. So I think there's a series of languages that are like, hey, we need to pump the brakes on this. It needs to be readable and transparent so that like the accountants can read it. Like I remember APL was like something that was written specifically so that like the record keeper or the accountant could look at it and say, this is the right operation that we want to run on all these records. I'm sure that, you know, a lot of the logic behind COBOL could be made more dense and more, you know, made to look something more like C or C++ or, you know, or anything else. But it really is just there to do, you know, business based. And when I say business, I'm talking like about numerically transactional based, you know, businesses, type transactions, just really, really fast and really, really efficient. And one of the other interesting things, and I'm not a math person either here, but there's like a way it stores digits. It uses something called binary coded decimal, which is different than floating point precision, I'm told anyway. So if you get into decimal fractions, there's a way that floating point digits represent this, or floating point digit representation does this, and there's a way that binary coded decimal does this. And when you get into those decimal fractions, you lose some precision over time with a floating point representation. It's that Office Space Superman 2 kind of thing, you know, fractions of a penny.
Yeah.
literally fractions of.
No, it's like JavaScript. There's a joke of 0.1 plus 0.2 is 0.304, right? It's like,
Yeah, and
um,
and you see that all over. It's like, where did that come from? It's like, it's close enough.
yeah,
And obviously, with the banks and all that kind of stuff, when they put out a decimal fraction, they mean a decimal fraction. So
yeah.
that's one of the other things you kind of don't see elsewhere.
Jeff, I was wondering, something else that would help me is that, we're all familiar with, we all use like our bank app, right? Let's say I'm doing a transfer to Nimit, and like I know a lot of these banks are hiring students, and they're building stuff in React, going to APIs that are being written in Node. Maybe like if I do a wire transfer to Nimit, how is that transaction like kind of like account transaction flowing through the system, and where does it touch the mainframe and come back out?
Oh man, great question. I wish I had a different chart or a chart ready for me here, but like there's because we have charted this out before, because you would not believe the amount of steps that these things typically take in the middle, especially if it's like a credit card transaction when you bring in like the clearinghouse and all that kind of stuff. But let's just say we're doing like a bank to bank transaction type of thing, where it's within the same bank, and we'll assume it's like the most simple implementation in the world. All that front end stuff is kind of like, do it however it works best. There's something happening with a front end UI. It's doing it's going to do its own stuff until it actually has to enter like the zone of the system of record. We kind of say that's the system of engagement that works with the user and gives them a pleasant user experience. At some point, that transaction gets transferred into like this is the unit of work that has to get processed. So at that point, in a modern mainframe environment, that's going to typically get transferred into like an API, a RESTful API call. And there's numbers of ways of taking like a COBOL application and sticking REST APIs into it, or extending it through REST APIs. So now I have like my very basic COBOL application that takes some input and makes some output, and I'm just going to say, okay, here's the REST API for this thing. And in a bank, it might not be REST APIs, it might be something more native, lower level. But I can take this COBOL program, put REST APIs on it. It can be a put or whatever. These are the parameters getting passed to it. It's going to do its thing, and it's going to return a 200 or a 400 or whatever. It's going to say 200. Everything went great. Send it back. At that point, for that 20 milliseconds or whatever, the system of engagement is sitting there saying, okay, I'm just waiting for this API return to come. Oh, 200. Okay, cool. Yep, your money went through. And at that point, it can, with a high degree of assurance, say that the backend system did its exact thing. There's a record of that transaction. Nothing needed to get rolled back. And the COBOL transaction happened. So it's kind of the instead of client server or server terminal or whatever, we are really thinking about this system of engagement to system of record. The mainframe is typically the system of record. It's the single point of truth that the front end applications interact with.
So something is because I see a lot of banks implementing things like Node.js in there to like you're saying, deal with their system of engagement. I think behind that, but I don't see a lot of like Node to COBOL or mainframe systems. So what typically is sitting in between there? Is this kind of where Java and C# make their, or is there something even older than that? I think of like this onion, this needle going through this onion, right? And I'm thinking like I'm sending 4 numbers down, right? My account, your account, and the amount and the transaction date or something, right? I'm sending those 4 numbers down. First, it goes from my browser to the Node app. The Node app goes to what goes to what, and then those 4 numbers go to COBOL that records it in the system, right?
So it depends how it's set up. I mean, it could be talking to like an MQ type thing where it's just going to stick the work unit on the queue, and that talks to COBOL, or that COBOL could be extended to APIs, and there's a program called ZOS Connect. And ZOS Connect is kind of like the single point for any business program or any program really running on ZOS, that's somewhat modern and somewhat extensible, or anything that's standardized really. It's like I said, you can just stick the API endpoints into it. So it goes from from Node.js to ZOS Connect into COBOL, or whatever transaction manager is sitting in between. You probably wouldn't have it sitting out there by itself, but it's going to be, actually, yeah, let me stick another layer in there just to make it, truthful. There's going to be your Node.js, which is making like a REST API call or an MQ call to something. There's going to be some intermediary layer to handle the billions of transactions coming in. That, whether it's ZOS Connect or IMS or Kix, is then going to drive the COBOL on the other side of it. So it's not. Connect. Yeah, we try not to stick up too many. I mean, architecturally, you wouldn't want to say, okay, well, we need to buffer the age of things, like stick some Java in there and then some C#. The ZOS Connect is really built to take long-standing business applications and REST API enable them, or just use Kix or IMS, which are rabbit holes of their own, which handle all that transaction kind of stuff.
I see. This starting to make sense. Like I'm thinking of ZOS, I can like expose a bunch of functions. It also oftentimes creates some kind of API, maybe not HTTP, but some kind of API that's discoverable, and then I can plug into that.
I mean, one of the big, when we say modern mainframe, in the past, I think we're enough in past this now where I can say this without anybody getting mad, but like we used to say like, oh, the distributed and cloud is that other thing. We're mainframe, and eventually they'll come back and start using us. And we really start understanding that like, no, there's real value in distributed and cloud, and we need to play in that. So the idea of taking everything that's available on the platform, whether it be on the application side or even the system management side, and making it available through APIs or like, just standard calls through like Ansible and stuff like that, we can actually just say, use your open source tools and call it. It's just a pool of resources available for you. So that effort started a number of years ago, and now it's to the point where anybody doing something on a mainframe, they're going to use modern tooling, and unless they really peek under the covers, they're never going to see JCL or green screen or anything that's really specific to the platform, other than just like the way it's architected.
So I want to oh, sorry. Go ahead, Nimit.
Yeah, I mean, I was going to ask about So I think I've learned a lot from this discussion around how like the entire ecosystem of COBOL and mainframes and the IBM Z platform and all that. I'm curious. Like we have a lot of students who are graduating and they're looking for entry-level developer positions.
Yep.
And this seems to be an area where, even though maybe it's not like the sexiest in the media, in a sense, like it seems like there's a lot of demand for new, fresh blood, basically people who are interested in doing this, and there's a lot of jobs. And so how does a entry-level developer go about kind of entering this world, getting their first job, etc.?
Right. I mean, it's a great question. If probably the best place to go is if you go on openmainframeproject.org. That's really like the hub for this whole effort right now. There's a job posting board where you can say, I have COBOL skills, I want to do this, or I'm a company looking for a COBOL programmer, I can do this.
Or what if you don't have COBOL skills? Like, are companies starting to build these like internal boot camps where or is IBM doing that maybe, where it's just like, just take smart people and...
I think one thing I want to dig into, because the myth I hear, right, is that COBOL is written almost by exclusively people, who came of age in programming in the 60s, right? So they're approaching their age of retirement, or they want to retire out of the field, right? And so there's going to be this demographic bomb in COBOL programming capability, and yet banks are not. Everyone who's decided to upgrade has upgraded, but there's still like I think IBM stat, right, 240 billion lines of code of COBOL running out there, and so a lot of this can need to be maintained, and businesses change and business rules need to change. And then the other thing add on is that a lot of these companies are so desperate, they're out there paying $200, $300 an hour for COBOL consultants because they just need anybody who can help them. So I guess the myth is that like if no one, it's like this untapped gem in the job market where if you learn COBOL, your skills are very valuable and very secure. So is this a myth? Is it maybe? Or I've always thought of nothing that's that good sounds that good is always completely true, right? So I love to
Right.
get your thoughts on what's the reality here. Is it what's true, what's not true, and then
It's probably a mix of anecdotes and truth in there. If you are a hired gun COBOL programmer and you have lots of experience fixing people's programs, updating them, adding new fields into them and stuff like that, you could probably come into a company and say, here's my fee. I know exactly what I would do to fix your thing. And, and walk out the door, and they'd call you back before you got to the door. Right. If you have a proven track record of writing COBOL, I know people who that's what they do. They go into situations, they fix situations, and then they're on to the next situation.
and then they can write their own ticket on what
might cost and what
I can't get into certain details, but when someone says that like our COBOL program, or there's a problem because of our COBOL, there's almost no chance that like the COBOL all of a sudden stopped working. There's something else in that chain, in that ecosystem that fell apart or hasn't been maintained. And it could just be that, when something works fine for a long amount of time, you stop keeping an eye on it. Like the water heater in my basement, I haven't thought about it except for these COBOL analogies in years. If all of a sudden it stops working, I'm not going to be like, oh, hot water heaters are the worst thing in the world. And it's like, oh, shame on me for neglecting that thing and realizing that like there was a leak on the bottom of it, right? And it kind of gets that way with COBOL, because it's kind of like the electrical system, right? It worked, it performed the business function, and I put in these numbers, I got out that number. That's my company's formula, and everything works fine. From a job market perspective, what I would say is, if you spend a week, the learning curve for COBOL is so, I don't know if I say shallow or quick or whatever, but you hit the end of it before you realize it. It's not like you can just keep opening doors. Eventually you do hit the end of COBOL and you're like, okay, I know COBOL. You can find jobs with that. There's a company we worked with, Black Knight Consulting. They have I hope they still have this group called the COBOL Cadets. It's a group of people they just brought up in-house. They're a financial services industry company. And they just train people to work on COBOL programs. I think
COBOL people love these like alliterations names.
Yeah.
There's like the COBOL Cowboys.
the COBOL Cowboys.
And there's some Captain COBOL.
There's
all kinds of.
Well, back to the how you learn it. It's a great time. I think O'Reilly just put out a bunch of their COBOL training material. Everybody's been making stuff available, and it's because it's hot in the news right now. If you go to openmainframeproject.org, there's a COBOL course, the one that I was helping to some degree right out there, and that gives you free access to a mainframe system. You log in, you try out all your code, you do it using VS Code. You don't need a green screen or punch cards or anything like that. It's all very standard, right? I have not installed. I got a new Mac like a year and a half ago. I made a point of not installing anything console based on it since then. So anything I've done on mainframe since then, I've done through VS Code and through browser based stuff, and I did that for a point, but also because like I like having my full keyboard and realizing that like I want my delete key to work the way that my delete key should work. So if you want to learn COBOL, that's one of the great ways to do it. That course is out there. I spent the last week or so recording that content in a video series, which will also be available, I think, through Coursera and Pluralsight. We're going to try to make it available through as many other platforms as possible. But like, it's me walking you through all that material, and you'll see that it's just like, the people who got their arms raised highest about like COBOL mainframe, if you showed them 20 different snippets of code and said, okay, person who has the loudest opinion about COBOL, point out which one of these is COBOL. I guarantee you, like 1 out of 8 would find it. Like, because they just have this visceral reaction. You tell them COBOL and they picture like a mainframe with vacuum tubes and those spinning tape drives in the background, because
everybody puts a picture of like
oh
Admiral
god, that
Grace
picture
Hopper from the 50s and 60s,
yeah,
like
and
talking
and
about
people
COBOL, like that's what we were imagining.
and people make this connection where they say like they say, okay, well, this is COBOL running on a mainframe, and they go like, so they're sticking punch cards in one of those Jetson space age beige computers in a basement. Like, how it's I think it's funny now. I used to get really frustrated with it. It would be like if you said like, I bought a new server. I bought a new server, and someone goes, oh yeah, I had an Apple IIe. And they just based everything on that. So when I say, yeah, we just put out a new mainframe, and they're like, oh yeah, I remember mainframes, like, and they don't realize that, like, the newest one is, yeah, I mean, it has, you can trace the lineage, sure, but I mean, when you consider like what is in this platform, there's few hardware and architectural platforms that move as fast as mainframe now. Like the biggest, baddest system. And again, I'm not trying to sell a mainframe, but I just want to, like, kind of shift people's mindsets here. It's got like 165.2 gigahertz SMT processors in it. It's got, I wrote it down somewhere because I didn't want to get this wrong.
Wow.
190 of them, up to 40 terabytes of memory, and you can run 85 of those logical partitions inside of it. It's 4 19-inch racks that are 40U high each. You can up to 4 of those. You can have a little smaller one too. The banks buy the bigger ones. They buy multiples of them. And it's just packed full of IO going out to disk and network and crypto and everything. It's a monster. And people still, when you say mainframe, they still picture like a thing just beep, boop, 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 in the background like that.
Let me ask you, because every year for go ahead, Emmett.
Well, I was gonna say, like, you're still making like mainframes sound big, but somehow my intuition right now would be that now I'm hearing about even like satellites, right? Like satellites in space, we expect there to be these like massive things, and now they're just like these mini satellites that are you can pack them in a tiny little box. I'm like, if I can have a MacBook Air that was like 10 times as powerful as my massive desktop 10 years ago, like, why does it make why are these mainframes so big? Like, it feels like you should be able to make them as big as desktops. They're still called mainframes, maybe because they have hardware that actually is very customized to their use case. But
yeah, and the mainframe word, there are some people who don't like it when people get out there and say mainframe, because people think mainframe. But it is the type of computer it is. It's like a graphing calculator is a type of calculator. A PlayStation is a gaming PC or gaming computer, right? It's a mainframe type of computer. If you actually look at like the breakdown of where all that real estate in the rack goes, the processors and the memory, they live in one very central part of it, the CPC drawer, and that thing is just packed full of memory and processors. The rest of the machine is really just something. It's really blades. They're PCIe IO cards, and they'll have like 4 to 8 ports on them, which connect them to other mainframes or out to fiber channel storage or to networks, or some of them have no ports on them and they're just there providing like hardware crypto and stuff like that. So the space actually taken up on a mainframe, and I wish I knew the actual specs. It's like 15% processor stuff. A certain part of it is like cooling, as it has to radiate, get rid of all the heat that's built up within this stuff. And the rest of it is all IO and battery backup and stuff like that. So
I see.
At the end of the day, it's just a computer with all it. It's basically a distributed data center with all of its parts in one place.
Yeah, I kind of think of this analogy of, and I think most of the modern web is in the, we've been thinking in the Google way, right? Commoditized hardware scaled in the data center, and this to me seems kind of like the Apple way of hardware and software all integrated. It's like, if I know that this is this distance from here, this is the heating specs on this, I can do different kinds of, kind of what do you call it, like SLAs across, reads and writes and stuff that I can do this mainframe, but I can't guarantee when it's just commoditized hardware going into commoditized networking equipment.
Oh yeah, and plus there's certain aspects of compute that you can now consolidate. So now instead of having like a little power supply that might fail in hundreds of servers, I have like 4 redundant super duper power supplies across the top of all these things, and they're plugged into different circuits of the raised floor in case one of them goes down. Redundancy is kind of built into it that way. And I'm sorry, I feel like I'm trying to sell a mainframe, but like it's
I wouldn't worry. I don't think anyone's on YouTube shopping for mainframes. It's not like
I know. Well, I don't even know where to buy one.
Yeah, I don't know if Google is going to run an ad on this and says like, "Hey, interested in mainframes?" And someone's going to click it and say, "You know what? This $50 million thing, I just,
that would be the ultimate irony right there." But like we've talked a little bit about the operating system kind of stuff. We'll say like you have like up to 85 on the Big Daddy machine, different LPARs, different operating systems running at the same time. And they are basically air-gapped machines. They can be as interconnected or as separate as you want them to be. So one could be running
LPARs
Linux.
Are the equivalent of like VMs. What's LPAR stand for?
Logical partition. So think of it like a map. Think of a mainframe's resources like a map with no boundaries on it. And you say, okay, I'm a blank slate. I'm gonna start this mainframe out, and I'm just gonna grab 8 dedicated processors and 3.5 shared processors and 2 terabytes of memory and these IO cards. This is my first LPAR, and I'm gonna call it LPAR 1, and I'm gonna install Linux on it. And now I've got this one system running right here, and then I can define up to 84 more LPARs running various operating systems, levels of operating systems. If they're in one of those parallel sysplexes, I could define one that's a coupling facility and hook those all up into that one. And because I've seen other like high-end servers where the servers that you spin up, those partitions are electrically isolated. So basically you're like physically splitting a server down the middle, or you're combining 2 chassis together. There's a hypervisor called PRSM, I forget what it stands for, but it actually manages the interrelation between the physical hardware and the logical representation. So you can share processors at like a 0.01 level, at least a 0.1 level between all of them. And you can say, yeah, this gets X number of shared processors and this number of dedicated processors. The priority for these processors goes to this one, and it's all managed at that hypervisor level. So it's a little bit different from a virtual machine because you can't just install one big operating system on a mainframe. That has to be LPARs. But it's I don't know. It's cool. When I first started working on a mainframe, that was like the goal. Like I want my own LPAR in one of these things, because typically you would take there's an operating system called VMware, or an operating system called VM that came out back in the 60s, and it does virtualization. It does an incredible job at virtualization. And that's where you would spin up like thousands and tens of thousands of Linux instances. And, you could have your own Linux, your own ZOS for testing and scalability and stuff like that, all within one other operating system running within one LPAR. And it just keeps on going.
It's like, it's almost like a whole, yeah, I'm sure, like there's so many different ways that we're thinking about cutting up, and isolating work these days, right? We have hypervisors, VMs, and now containers have really dominated. Right. And so it's like, and now I guess you're saying that you can add mainframes can do another level of this LPAR. So you can have LPAR running Linux, that's running a VM, and running containers, kind of all.
Yeah, you can run, as of I think it was last year's release of ZOS, you can run Linux containers within ZOS too.
Oh, straight on the hypervisor.
Oh, well, it's within the within the ZOS operating system.
Okay.
So it's mostly, I mean, it's a really neat technical feat. It's a really interesting business feat, and I say it because when you talk to the people that run mainframes, run mainframe applications and system programmers, that's system. We talk about different worlds with different terms. System administrator in mainframe is typically called a systems programmer, and that scared me at first because I'm like, I don't want to program. Like, relax. But the system programmer, they typically only handled ZOS type stuff. So if you wanted to like bring up like a Linux to handle like you said, like the front end side of something, you had to talk to the Linux department, which might, if you're in, Pocatello, Idaho, they're out in Ogden, Utah. Now you have to, it's two different departments because they handle Linux and you handle ZOS. Well, now you can just, if it's something that can be containerized, you can just spin that up within ZOS, which is its own operating system. It kind of feels like Unix, but a little bit different. And then you just spin up as many instances as you want for as long as you want, power them down, all that kind of stuff. So any type of logic that you need from a Linux program, you can spin up in ZOS now. So there's lots of ways you can get to Linux or Unix within a mainframe. I mean, virtualized, containerized. There's even a system which looks suspiciously like a mainframe called a Linux One. And it's a system which looks suspiciously like a mainframe that only runs Linux. So that kind of satisfies the need of like, I need the hardware reliability of that big thing, but I don't want to get into the whole, mainframes type of stuff.
I see. Wow. Do you think that I feel like there's these two worlds that have separated, and I can see that the one side barely knows the other side exists.
Yeah.
And one side is probably saying, "Look at you guys over there reinventing all the stuff that we figured out in the 70s." Do you think ever these two shall meet? Like, what is the future of mainframes? Do you think mainframes?
Oh God, I hope so. I hope so. Yeah, that's a really good way.
Ecosystems in the world that if I ask 90% of my students, I think, and I said, "What's mainframe?" They would have the movie representation at best, right?
Right. Yeah, or something from like a Bond film or something like that. It's become like a movie trope. Like the mainframe is just like the thing.
Yeah.
Cut the hard line to the mainframe.
Cut the hard line.
I think that was in an episode of Community we just watched. But yeah, man, we that is my goal. That is my dream. Is that because I've always said that I would know if I started my own business, I would know that I was successful if I needed a mainframe to run all of my stuff. Somebody starting a business today, it might not enter their mind unless somebody talks to them and shows them like, no, there's this whole thing going on out here. And if if you want to learn about it, I'm stalling so I can look up something. Eventually that system of integration, a system of record, system of engagement kind of model is a good way to go. There's the recent partnership or acquisition of Red Hat is playing directly into what we're doing, what IBM was doing with mainframe. There was an announcement the other day about Ansible for ZOS. Typically stuff shows up on Linux for the mainframe first, and then if it has a business, real business value for our ZOS customers, then it becomes available for ZOS. The fact that somebody can come in with like, Ansible scripting experience and get to work on a mainframe with just somebody showing them like, here's your playbook, here are the scripts, that's exciting. But yeah, I would love to get to the point where people are writing code that are just doing a fantastic job of that system of engagement, and then at some point say, this is the stuff that needs to run every single time. Let's pass that off to the mainframe side.
Yeah, I do wonder with this trend of serverless, if people are again going to the mindset of like, I just want to write logic that can be encapsulated somewhere.
Yeah,
whether or not that's running in Lambda. That's interesting what you said about IBM, because I feel like IBM, we think of Red Hat as almost very back end, right? It's your server, what your server is running on, but IBM almost thinks of that as a front end, right? Red Hat is powering the system of engagement, right? It's like beyond the system of record, so it's like it's in front of where IBM sits as the mainframe provider.
Right. Yeah. And that's kind of how I see it. I mean, and when I say IBM, I'm just another reminder, not speaking for IBM and talking for a guy, Jeff, who happens to work for IBM. But yeah, we're talking about IBM Z, the mainframe, which typically says, let us handle the important stuff. Not that the front end stuff isn't important, it's incredibly important, but like the highly important transactions, those very valuable transactions. We work with, a number of credit card companies and banks, and I wish I could name names, but like they tell us like how many milliseconds they have to process a credit card transaction and look at it for fraud and make sure that like this transaction should go through it all. and like the different code paths that one swipe of a card happening from any number of tens of millions of cards at any number of tens of millions of terminals anywhere in the world coming in at any time has to be cleared. And they're like, yeah, we like our mainframe, but trust me, if there was something better and something cheaper, we would use that. And I keep telling them, please do. Like I'm a technologist first, you know, if there's something better, you should be using it. If something beats us, that deserves to beat us. But the people that we work with who get it, who stay on the cutting edge, who keep their software updated, the ones that keep driving us to, you know, you should really do this, you should include this should be better. Those are the ones getting the most value out of it. And I to be honest, those are the ones who are the most fun to work with. When you sit down with a company, oh my God, I can't name names, but like the people wear brown shorts and drive trucks around, and you talk about like, you know, what are they trying to solve? What do they want to make available next year? And then you consider the scale that they're trying to make this happen at, and you realize this isn't like, yeah, I wrote a new Java program, stick it in here and make it work, because it needs to not only work but work faster. They're talking about fractions of a millisecond. Those conversations are so exciting, and it's actually a conversation with that company that made me look into mainframes in the first place, because it really planted a bug in the back of my mind about like, wait, what computer exists that lets them do all that stuff? Oh, it's not just one computer. Okay, well, how do you make two computers talk to each other? Oh, and that's what really opened the door about like architecture as a thing, and beyond, not just, you know, stuffing a computer full of resources.
Well, I can definitely. I mean, I think one interesting cultural difference between mainframe world and programming world is that, you know, when I see advertising from mainframe, I often see like, we process this number of transactions per second.
Yeah.
Right. And it's kind of hard for web programmers to think that way, right? Because
yeah,
you look at a microservice architecture, how many transactions this thing can process per second? It's every system you have is like giving you non-deterministic performance, right? How you gonna aggregate that and just say like this number of transactions, right? It's a lot of times like, performance graphs in web world, it's very much like percentile based, right?
Yeah,
like,
and if somebody looks at your code and goes, yeah, how many transactions a second did this run? And like, I don't know, where are you going to run it? How many of them are going to? Yeah,
so
it's you really have to, whenever there's one of those numbers, there's usually an asterisk, and it pays to see exactly what type of transaction it's talking about there.
Yeah. But it's like, I can see a business saying like, look, if we really need to pump in 100 billion like warehouse inventory moves per year, I need to know that system that can handle. I need to buy something that can handle it, and I'll pay whatever premium there is. I'm not going to run this on a bunch of, you know, Python scripts.
Right. When I go into, I mean, when I see like what Netflix does with their like eventual consistency model, they make an art out of it. You know, they really embrace the fact that consistency across their databases, it is a fluid kind of thing. And they, you know, with what they've done with Chaos Monkey is interesting. They embrace and accept the fact that things are going to be going down and moving and all this kind of stuff. And when I talk about that to like a newer programmer or somebody from the distributed cloud side, they're like, yeah, that's kind of cool. When I tell that to somebody who's been like working on, you know, a mainframe sysplex that hasn't gone down in 20 years, I'm like, yeah, they run this thing on their production systems called Chaos Monkey. They're like, they do what? So the idea of just like, there's going to be X percentage of systems that are down, and they're not going to take an action until X plus N percent are non-functioning, and it works because it's built that way. It is two different models, but there's also different businesses that can tolerate that. I mean, eventually we'll probably get to the point where financial institutions can dabble more in eventual consistency, but there's a large retail company that we work with, who I'm pretty good friends with, and the idea of eventual consistency of like a truck maybe not being full, or a store maybe not, you know, what's on the shelves, I don't know, let's keep hitting refresh until we get an average answer. That scares the crap out of them.
Yeah, no, I'm sure like when you map things into the real world, it starts being much more important that the systems are, you know, like you're not losing transactions, right? Like,
yeah,
how I mean, I guess it's a business problem, right? How many packages can I not transact in my or not let the transaction go through my system per year
Right.
before I start having problems, right? Like
Yeah, I mean, I used to work driving a beer truck, and that was a fun job on the Jersey Shore. And like if I knew I had 60 cases of Miller Genuine Draft going out, I would put 62 on the truck just in case. And it might be that I broke 2. It might be that I accidentally put 14 in one store when I was supposed to put 12. But like, you know, you plan for that kind of stuff. When the actual product being dealt with is money or properties or titles or anything like that, it's harder to put in that cushion like that, I guess.
Jeff, I wanna wrap up with every year for April Fool's Day we do this. we make this website, and I can't tell if it's a joke and if it's a real thing that shouldn't be a joke, or if it's if there's real kind of, if it's satire, or if it's actually the best idea we've ever had.
Those are the best. I'm telling you right now, that's the best idea ever.
I don't know if you know, we Full Stack also runs a program called Grace Hopper, and so we're familiar with that. So I'll put it on the screen here. So this is our website, gracehopper.com, and we always announce that we're launching the world's first COBOL bootcamp. Full stack COBOL, because another thing that we do is we teach all JavaScript, so one technology across the whole stack. And this is truly like one technology. And so I'm curious if you think, like, is this something that the business world needs? You see, like, built for scalability, eternal simplicity, business oriented. We got the hello COBOL in there. So I'm curious if you think, like, if this is something that actually, like, you talk about the COBOL cadets, right? Like, are companies out there? Like, are companies out there thinking that something like this should exist? Are they going to universities? Who's solving this problem for them right now?
It's a good question. I can say that when we put up the course on Open Mainframe Project, there have been thousands of people signing up for it. It's been extremely busy with people learning it. As far as companies hiring people to fix their COBOL, I'm not sure of those numbers exactly. It's not like a company is going to have 8,000 COBOL programmers. For the most part, it is going to be maintaining code. It's going to be adding new functionality to existing, core business logic, that kind of stuff. What I would say is, if you're into technology and you haven't picked a language to major in, and you're in an area where there are banks and they're hiring, and you see COBOL as a thing, that is a huge foot in the door. If you say that especially if you say I have COBOL programming experience on a mainframe, that is going to get you a call back. Absolutely. Because, I have companies, calling us saying, where do I find these people? And I have students contacting me saying, how do if I learn this, where do I get a job? And a lot of what we do is matchmaking in the division that I'm in. There are jobs, like you said, they might not be as sexy as coding, the UI kind of stuff, but it really, when you work in business logic, it really puts you close to the business, and you get to understand what the business needs are coming up, where their shortcomings are, when if you're a retail business, where the sales are going to be. The business can't move if the back end IT doesn't support it. So you become very entrenched in those high level business decisions. And it's, you're not just in a basement writing code. You're connected to that kind of stuff.
Awesome. Well, thank you so much, Jeff.
Right.
It's really enjoyable learning. Can
I give one more plug for?
Yes, of course.
Masterthemainframe.com. This is something I'm really happy that I get to work on. It's an annual contest. We've been doing it for 16 years now. We kicked it off, like I said, 16 years ago. I was on the team that started this. We basically took a spare mainframe, a spare LPAR and a mainframe, and we said, let's set up an obstacle course for students to log in and prove that they can learn mainframe stuff in a couple of weeks, because there were people saying we need somebody with 30 years experience. And we said, no, we can train somebody in this in a couple of weeks. So we set up this contest. We gave away shirts if they did it. It's been wildly successful. Last year, I think we had 2,500 students signing up for this thing, logging into an LPAR on a mainframe. That's how many we can support. We want to go higher, but we're getting ready to kick off the 2020 version of it in September. It's all VS Code based. You're going to be logging into one of those fancy new Z15 mainframes, and you'll get hands-on experience. And there's lots of opportunities at the end of it to get jobs. So, if any of this was interesting, do that.
Awesome.
You said the magic J word.
This was fun. I had a lot of fun talking with you guys, and I really respect the work that you do. I mean, I love your style, and you're doing fantastic work.
Appreciate that, and thank you so much for your time and insight.
Absolutely, thank you.
Yep.